Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about some attributes of quadratic functions. If we look at these linear and quadratic functions here, this is an example of a graph of linear and quadratic functions. Some commonalities that they have is they both have x and y intercepts. Some characteristics of quadratics that's different from linear is if you look at the quadratic, it has a shape of a parabola and it changes from increasing and decreasing. Alright, whereas a linear function is constant, it's either going to always increase or it's going to always decrease. Let's label a parabola or a quadratic function. So you have a vertex. Vertex is the maximum or minimum point of a parabola. That's going to be this area right here. This is going to be your vertex, which is also going to be a maximum or minimum, which is the y value of the vertex. So let's say this is 1, 2, 3, 4, right? So your vertex is going to be, and then 1, 2, 3. So that's what? 3, -4. That's your vertex, all right? But you want to look at the y value. So the y value is -4. 0 is at the point at which the parabola crosses the x-axis. So it crosses the x-axis here, and it crosses the x-axis there. So that's a 0. And then the y-intercept we know is when it crosses your y-axis. So if we were to label this, this is your y-intercept, it's where it crosses your y-axis. This is your 0 because it crosses your x-axis. And then you have another 0 where it crosses your x-axis. And then this is your vertex, which is also called the maximum and the minimum. This is the minimum, all right? So anytime you have a parabola that's upwards, the vertex is the minimum. Anytime you have a parabola that's downwards, the vertex is the maximum. All right, so let's take a look at this. All right, let's take a look at this parabola. All right, we want to determine the vertex. All right, so the vertex is here, all right, which is 0, 6. That's your vertex. All right, maximum, minimum. So this is a downward parabola. So this is a downward parabola. This is a maximum. And all it's saying is this is the highest you can go. You can't go above 6. All right, so that's why it's the maximum. Zeros. How many times it crosses the y-axis? It crosses it twice. It crosses it here, all right, and it crosses it there, but it's only your x values. So it crosses it here at -4, and it crosses it here at +4. Your y-intercept, that's going to be the same as your vertex because it crosses your y-axis, and that's going to be 0, 6. And then this is from our previous lesson. We want to determine when it increases or decreases. So your vertex is actually going to help you with increase and decrease. The vertex is at my x value. The vertex is at 0, right? And so you want to see what's happening when I go from negative infinity to 0, and then what's happening when I'm going from 0 to positive infinity. So as I'm going from negative infinity to 0, as my x increases, my y increases. So it increases here. It increases when x is less than 0. And then from 0 to positive infinity, as x increases, y decreases. So it decreases at x is greater than 0. It's positive when it's above your x-axis. It's negative when it's below your x-axis. So again, looking at your zeros will help when it's positive and negative. So my zeros is -4 and 4. All right. So looking at that, it's saying that it's going to be positive when x is less than -4 because it's above it, and x is greater than -4. All right. So it's going to be this area right here. So x is greater. I'm sorry, I said that wrong. I apologize. This area right here is positive. Only these values is positive. So it's going to be a compound inequality. So it's going to say x is greater than -4 but less than 4 because this area is positive. Apologize for that. Now my negatives is below the x value, all right? And my negative is going to be when x is less than -4, because all that's negative, and x is greater than +4. So x is less than -4 or x is greater than 4. Describe the point where f of x changes from increasing to decreasing. Your vertex is that change, that point, all right? So it changes at your vertex. That's the point when it changes from increasing to decreasing and vice versa. Describe the points where f of x changes from positive to negative. All right. So it changes from positive to negative when your zeros. All right. Your zeros help indicate the change from positive to negative. So those are indicators to help you determine increasing and decreasing and positive and negatives. All right. So let's take a look at this. And we want to look at these graphs. And we're going to try to fill in these characteristics. The vertex. Vertex is here. All right. And so my vertex is at 3 and -4. 3 and -4 is going to be the vertex, maximum or minimum. So it's an upward parabola. So that means this is the minimum. So that means at least -4. So -4 is the starting point. -4 and up. So that is a minimum. All right. And so when you're looking at this, if it's an upward parabola, your vertex is minimum. If it's a downward parabola, your vertex is maximum. Zeros. So it crosses my x-axis twice, crosses my x-axis at 1, and it crosses my x-axis at 5. So your zeros is 1 and 5. Your y-intercept, where does it cross your y-axis? It crosses my y-axis here at 5. So 0 and 5 is your y-intercept. Let's do the same thing for number 3. Vertex is going to be here. Now, vertex is going to be at 2 and 4. That's your vertex. It's a downward vertex. All right. So, a downward parabola. So it's a downward parabola. So that lets me know that my vertex is the maximum. All right. And then is a maximum at 4. All right. How many zeros? It crosses the x-axis twice at 0 and at 4. And then the y-intercept, it crosses my y-axis at 0. So 0, 0 is going to be your y-intercept. Now, let's look here. Vertex. All right, my vertex is here. All right, it's going to be at -4 and 0. Maximum, minimum, it's an upward parabola. Since it's an upward parabola, my vertex is a minimum, and it's a minimum at 0. All right. The y-intercept, it crosses only one time. It touches your y-axis only one time. All right. So it's going to be at -4. So -4 and 0 is going to be, your x-intercept. It's going to be -4 and 0. All right. And then your y-intercept, where it crosses your y-axis, is going to cross my y-axis at 14. So 0 and 14. So this example here, it would ask like how many zeros it will be. So this is saying how many times it'll cross the x-axis. This will be only once, and it'll cross it at -4. All right. Number 5, looking at this, Takesha is comparing the y-intercepts for f of x and g of x. The function is shown. And so we got one graph, all right, that's f of x, and then g of x is in this standard notation for quadratic function. How can Takesha determine the y-intercept of g of x without graphing the function? So we already know the y-intercept of this graph, but with this, how do we can determine the y-intercept? Well, think about it. Think about the y-intercept for linear functions. To find the y-intercept, you just substitute x for 0. To find out what your y value is, you got your y-intercept. Well, you could do the same thing for your quadratic function. All you got to do is substitute x for 0. And when you substitute x for 0, you can find your y-intercept. So if I substitute x for 0, then my y value is going to be 5. All right. So your y-intercept is 0 and 5 for my g of x. If I look at my f of x, it crosses at 5. So the y-intercept for here is 0 and 5. So they both have the same y-intercept. All right. Number 6 says, hey, sketch a quadratic function with no zeros. That means it does not cross your x-axis at all. So you could just do any function. It doesn't matter if it's like positive or negative. As long as it doesn't cross your x-axis, then that will be a quadratic function with no zero. This is an example of what that would look like. Number 7 says, hey, Ms. Wade asks her students to graph g of x equals negative 2x minus 4x. Jillian claims g of x will have a maximum value. Rachel claims that g of x will have a minimum value. Who is correct? You got to think about it. Think about your a value. So if I have a negative a, my parabola is going to go downward. If I have a positive a, my parabola is going to go upward. So if I look at this quadratic function, it's a negative a, so that means it's going to go downward. If it goes downward like this here, then that means our vertex is a maximum. So if our vertex is a maximum, then that lets us know that Jillian is correct. Jillian is correct. Right. So now let's look at this here. And so Rashad and Tom are playing a game of ping pong. We're looking at the graph here to answer these questions. What is the vertex? So the vertex is here. All right. This is the x, this is the y. So the vertex is at a half or 0.5 and 1.25. What is the meaning of the vertex? So this represents the maximum. All right. So the vertex can tell us where the ball changes from increasing to decreasing. And it can also show the maximum height. All right. So just to recap here, we're looking at some attributes of our quadratic functions. We determine our vertex, which is that point at which it changes from increasing to decreasing and vice versa. Your vertex can be either maximum or minimum. If your parabola is going upward, that vertex is a minimum. If your parabola is going downward, that vertex is a maximum. We talked about our zeros. Our zeros is where the parabola crosses your x-axis. That determines your zeros. Your zeros help you determine your positive and your negative values on your parabola. Your y-intercept, of course, is where it crosses your y-axis. And so I hope this helps with our understanding with attributes of quadratic functions.